Okay, let's continue. Okay, normally there are four major biological materials. Okay, the first one is carbohydrates. Okay, carbohydrate wasn't like sugar. Sugar like glucose, cellulose, right? Those things belong to carbohydrates. Okay, carbo means carbon. Hydrogen means water. And this is a source of energy. This is source of energy. And some of carbohydrates also used as a structural component, for example, like cellulose. So for example, like sugar. Structural component, for example, like cellulose, 纤维素. Right? And some sugar can also use for identification and communications. And nucleic acid, there are only two kinds. One is called DNA, the other one is called RNA. So it's a blueprint. It's the code for protein synthesis. Okay. The next is protein. So protein is a sign of the reaction of the metabolism, right? Protein can be used to transport, for example, like hemoglobin. For example, like hemoglobin. Hemoglobin.
Oh.
Okay, hemoglobin is the protein to transport oxygen. Okay, for example, like some protein can be used for storage, for example, like capsid. Okay, capsid. Structures like collagens, and defense like antibody. Okay, lipid also can be served as a storage of energies. Okay, the membranes, phospholipid is the outer surface. Okay, the membranes of the cell. Okay, I mentioned this, right? The biosynthesis or the so-called anabolisms. Okay, so it combines the small molecule into big one. Okay, in the opposite, for energy production via catabolisms. So it breaks down the larger molecules into smaller one, and also release energies. Also release energy for biosynthesis. Understand? So they interact with each other, right? Okay, let me talk about some things. Biosynthesis. Okay, biosynthesis combine smaller molecules into a big one, but it requires energies. So where is the energy from? From the catabolisms. Catabolism break down the larger molecule into smaller one and release energies for anabolisms. And the west is so-called metabolism. Okay, next I want to talk about the microbiomes. I want to talk about the microbiome metabolisms. Okay, microbiome metabolisms. The common source for cell synthesis. Okay, common source for cell synthesis from organic matters. Or from organic matters. For example, like heterotroph. Okay, from carbon dioxide. For example, like autotroph. And energy source for cell synthesis. Okay, there are two ways. One from light, the other one from chemical reaction, especially the redox. Okay, redox stands for reduction plus oxidations. The one use light, we call them. The ones use light, we call them phototrophs. The ones use chemical reactions, we call them chemotrophs. Understand? Okay? Okay, so let's put them together. Okay, if we use common source, there are two kinds of organisms. One is called heterotrophic. The other one is called autotrophic. Heterotrophic means you need to eat others. Okay, eat others and break down their fractured meats, into your nutrients. Okay. The ones they do not need to eat others. They use light, or use chemical reaction, use some inorganic carbons. We call them autotroph. The auto means self. Auto means self. Okay? Okay, the energy source, the electron donor. There are two types. One is you use chemical reactions. We call it chemosynthesis. 化学合成. Okay, the one use light energy, we call them photosynthesis. Okay, we call it photosynthesis. Okay, the terminal means final, okay? The terminal electron acceptor. If you use oxygens, we call it aerobac. Okay, anaerobic. Anaerobic means it doesn't need oxygen. Oxygen is not required for anaerobic, but it requires nitrates and sulfate. Nitrate and sulfate. And fermented was like organic compound. Okay? Okay, this is quick summaries for those things. Okay, let's do this. And the interactions. Okay, the interaction between the carbon source and energy source. Okay, the carbon source and energy source, and you can classify the organism into like photoneutral, photoautotroph, chemoneutral, and chemoautotroph. Okay? So let's see this slide. Okay, this slide shows you a few terminologies. Okay, the first one is obligate aerobase. 大家都有写到吗？都写到吗？目前前面这边有一些空白没写到吗？还是没有？ So effects of effect of oxygen on materials. Okay, first one is obligate. Obligate means must. Obligate means must. So obligate means must. So obligate aerobase means the oxygen required, and it's a must. So must have oxygen. We call it obligate aerobase. And the second one is called facultative anaerobics. So facultative anaerobic means they prefer, let me write this, so it's hard to understand, right? Let me make this easier for you to understand. Facultative anaerobics means they prefer oxygen. Okay, but they can survive without oxygen. So either way is fine. Okay, either way is fine because they have both. Either way is fine, but they prefer. So in the test script we say that greater growth in the presence of oxygen. So actually they prefer oxygen, but they can still survive without oxygen. Understand? Okay, next one, as I say, not all the organisms require oxygen. Okay, I say that in the early class, right? As I mentioned earlier. So obligate means must, anaerobic. So it means the oxygen will count them. Okay, we human beings, without oxygen, we die. But those organisms, if you give them oxygen, they die. Okay, that's so-called obligate anaerobics. Okay, number 4, aerotolerance anaerobic. Okay, so they prefer no oxygen. They prefer no oxygen, but if there is oxygen, they can tolerate. They can tolerate oxygen. Oxygen cannot kill them, but they prefer oxygen. They prefer oxygen. Okay, number 5, micro. Micro means small amount, little amount. So micro aerophilia, philia means light. So this kind of organisms, they just need low concentration of oxygen. Okay? They require oxygen, but just low concentration. Low concentration. So in opposite to microaerophilus is canophilic. Philic require high carbon dioxide. Not oxygen, it's carbon dioxide. Okay? So this is the effect of oxygen on bacteria. Okay, the reason I talk about this because we are going to do one questions. Okay, let's see here. Anaerobic respirations. Okay. Okay, we break down this into two parts. So as I mentioned, redox. Redox actually stands for oxidation and reduction, right? It stands for oxidation and reduction, right? So oxidation includes oxidation of carbon, right? So you can see that because it loses, the reason it's called oxidation because it is losing electrons. Okay? Oxidation of carbon, you lose electrons, right? And in opposite, reduction means gaining electrons. Okay. So the reasons, okay, I just want you to see this slide very quickly, okay? The reason we need oxygen for respiration is during the respirations, okay, during the respiration, it will produce 32. Some textbooks say 34, okay? 32 ATP. Okay, that's the reason without oxygen we will die. Okay, so during the cellular respiration, it will produce 32 ATP. Okay, that's it. Okay, that's it, student. Okay, so it's starting from obtaining glucose and glycolysis. Krebs cycle, electron transfer. After that, it obtains 32 ATP. As I just mentioned, what's ATP? ATP is some kind of cellular energy. Okay? And anaerobic process means without oxygen. Okay, so it involves four processes. Okay, four stage. First one is called hydrolysis. Okay, it means a complex molecule encounter water become a simple molecules. So hydrolysis means decompositions with water. Okay, so fermentation is anaerobic. It's anaerobic. It's anaerobic respiration. Okay, fermentations. And there are two kinds of fermentations. So quickly mention this. There are two kinds of fermentation. One is called alcoholic. It's called alcoholic fermentation. You will produce alcohol. The other one is called lactic acid. So you will produce lactic acid. Understand? So there are two kinds of fermentations. One is called alcoholic fermentation. You will produce alcohol. Okay. The other one is called lactic acid. Okay. Fermentation doesn't need oxygen. Doesn't need oxygen for fermentation. So some people regard fermentation as anaerobic respiration. Acetogenesis, it will produce acetate. Okay, the product of the acetogenesis is acetase plus hydrogen plus carbon dioxide. So mesogenesis will produce methane and carbon dioxide. Okay, let me quickly go over this. Hydrolysis means a chemical reaction requires water. So this complex breaks down in simple molecules. Fermentation, you can regard this as anaerobic respiration. Without oxygen, fermentations, there are two kinds of fermentation. One is called alcoholic. It will produce alcohol. The other one is called lactic acid. It will produce lactic acid. Okay, acetogenesis will produce acetate plus hydrogen plus carbon dioxide. And the last one, the final step, is the mesogenesis. Mesogenesis will produce methane and carbon dioxide. Okay, and this is the anaerobic reactions. Okay, this is anaerobic reaction. So see the word in green here. Okay, bacteria go for electron acceptor. Bacteria go for electron acceptor and yield the highest energy. Okay, so move from high to low. Okay, and then move down the tower when they are depleted. Okay, so this is nitrates, manganese, iron, sulfate, and fermentations. And because this one produces methane and carbon dioxide, so we also call it methanogenesis. Okay. So next, I would like to explain this so-called redox ladder. Okay. So from top to bottom, you can see the odors. So the oxygens, nitrates, okay, on top of it. So I want you to know, one thing I want you to know is, so the topper one got more energy, so most energy here. Okay, most energy here, and these, the bottom has these energies. So, student, please take a look here. So oxygens, okay, from here, right? So oxygens, from oxygen to waters, this is aerobic. From oxygen to water, this is aerobic. Okay, this is aerobic reactions. For nitrates, let me use another. From oxygen to waters, this is aerobic. From nitrate to nitrogen, this so-called denitrification. Okay? And from this to here, we call this sulfate reduction. Okay, carbon dioxide and produce methane, right? We call it methanogenesis. Methanogenesis. Okay, and the last one is water becomes hydrogen. Okay, as you can see, the energy yield decrease. Okay, here, okay. So, as I mentioned here, so the first one here, you should, students, take a look. Student, take a look. Here, student, please take a look. Please look at the screen. So you should compare this to this slides. Okay? So this O2 becomes water, this is this one. It's a reduction of oxygen. It's a reduction of oxygen, or you might call this aerobic oxidations. Okay? And second one is a reduction of nitrates. Okay? You might call this denitrifications. Okay? And from this table, you can see, so the conclusion is the energy yield. The energy yields, starting from plus 0.80, starting from 0.812, right, down to negative 0.244. So the conclusion is energy yield decrease. Okay, energy yield decrease. Decreasing energy yields, right? Okay, photosynthesis is used for storage of energies. And respiration is used for release of energies. Okay, however, energy transfer by organisms are inefficient. Okay, it's about only 5 to 15% capture. Okay, it's about 5 to 15% captures. Okay, and this is from textbook. I hope if you do not purchase, okay, if you do not purchase the hard copy, at least you need to find the electronic versions. You need to read it. Okay. Who doesn't have textbook? 谁没有教科书的举手 Who has the hard copy? Who has the electronic one? So you need to find. I think you can Google it. You can find the electronic versions on the internet. Okay. If you don't want to buy it, it's fine. It's fine with me, but you need to scan them. Okay. So I want you to know three things. I want you to know three things. Okay? Let me enlarge this. First thing is RC. Student. First thing is RC. RC stands for reactions for bacterial cell synthesis. And there are two. So these two belong to RC. Understand? And the first one is use ammonia as a nitrogen source. And the second one is called RA. RA means reactions for electron acceptors. And there are 4, from 3 to 6. And number 6 is use carbon dioxide. Okay, use carbon dioxide. So this is also so-called the methane fermentation. From 7 to 21. From 7 to 21 is called RD. RD stands for reaction for electron donors. Number 9 is carbohydrates. Okay, use carbohydrate, for example, like cellulose, starch, or sugars. Okay, as electron donors. Okay, right? And the last one, okay, from 12 to 26 also belong to R. Okay, what you need to know is this formula. Student, what you need to know is this formula. Okay, R here stands for reduction. So R equal Fs times Rc times plus Fe times Ra minus Rb. And one thing, Fs plus Fe equals 1. Fs plus Fe equals 1. S stands for synthesis, E stands for energy. So F means factor, okay, F value. Okay, so S stands for synthesis, E stands for energy, and if we add them up, it's equal 1. Okay, and table 6.5 in the textbook give you the Fs value. Okay, Fs value. So if you need Fe value, you just use 1 minus Fs. Okay, let me finish these questions. Okay, you might take a photo. Okay, this question is from textbook. Okay, let me finish this. I will let you guys go. Okay, this question asks us to write the balance rate reactions for methane fermentations. of glucose, maximum fermentation of glucose. And what is the quantity of ammonia nitrogen? So ammonia is NH3, right? So ammonia nitrogen, the nitrogen from ammonia. Okay, so we need to go back to this table. Okay, so maximum fermentation, do you see that? So RA maximum fermentations is 24.11. And use ammonia and nitrogen, that's RC. Okay, that's RC. And also use glucose, right? The glucose carbohydrates, that's 9. That's number 9 for us. Okay, the value is 41.84. Okay, so we got all everything. So first of all, let's find out from these tables. Okay, from this table. Okay, so it's these values, carbohydrates, and electron acceptance oxygens. So from table you can find out the RS. Sorry, it's this one, not this one. Carbon dioxide. So the Fs, this is Fs. So the Fs is 0.28, right? So if Fs is 0.28, then Fe is 1 minus 0.28. So we got 0.72. Okay? Then use something like Haas law. Use something like Haas law that you learn in general chemistry, right? So this is Fs. This is Fs times Rc. This is Fe times Ra. This is minus Rd. Okay, you plug in everything here. Okay, this is the final result. Do I have these slides for student learning? Okay. Okay, so the question B asks us to calculate the ammonia nitrogen used. Okay, so we have 0.196 grams of ammonia nitrogen. Right? So over 7.5, and the method attending 2.02 over 75, cells produced is 1.58 over 75. Okay? So please go back to textbook this question. I'm gonna ask one question regarding this. Okay, no matter in the assignments, okay, or events in your final exam. Okay? And the final exam will be housed. Please write this one down. The final exam probably will be housed in the last week of May. Okay, and then we have 2 weeks for PBL presentations. Okay, probably the last week of May. Okay, last week of May we will hold the midterm exam, the final exam. Okay, and probably the final exam will be held in the main campus. Okay, because I need to test my student as a PA. Okay, probably I need to borrow the classroom. Okay, if I can borrow one classroom, the final exam will be held in the main campus. Then you don't need to come here. Okay. Okay, that's for today. And I saw our classroom is very nice. Okay, he posted this vote. Okay, for vote for the teachers. So if you some of students, the former student, right? If you think my teaching is well, please just help. Okay, that's it. That's for today. Thank you so much. Thank you so much. 不要打断我学的。Okay, that's for today. But we do not take attendance. Let's do it very quick. Let's do it very quick. 点名一下。One point for attendance. Okay, you come long way to here, right? 来，那个快点啊！来，那个我点。秉杰在吗？秉杰。岳庭岳。孟轩有来吗？然后秉纯，那个少奇，有一个请假，好像是少奇，先记没来，等一下我再跟说有一个请假。嘉伟、少彤、燕轩，没有来就先。Stone， 陈阳、太久啊，太正，太正，没来。俊志、义祥，
他请假，他请假
是他。那个这个，这怎么念啊？义成、义长，没来。Renner， 阿飞 ，Axel，Bring here。